Okay, so in this lecture video, I'm going to go through the process of looking for outliers that I asked you to do using the program that I supplied. It's out there on Moodle. And so anyway, the first thing I'm going to do is I'm going to run this first portion of the SAS code. That's going to set up the path string in this macro variable. This is a macro variable right here. And it's going to set that macro variable to the path that I've given it that points to the directory that contains the data set. And then what I'm going to do is I'm going to use that path string in the libname statement, creating what's called a libref. This is a pointer to the directory that SAS recognizes, and it points to the directory that contains the data set. And then once I have defined this libref, then I use that when I create a temporary version of the data set that I'm calling outlier.dataset. And anyway, so what this is doing, this is essentially a shorthand way of pointing to the directory that contains the data set. And then here we have the name of the SAS data set in that directory. So when I run this, it's really not going to show us anything because there's no output to show. But if I do go to the log, then it will tell me whether or not it was successful in creating the libref. And it was successful. You can see here that it was successfully assigned or created. And then I created a temporary version of that data set. And it tells this was successful. We see that there are 100 observations in the data set, and there are 4 variables. Now, if I wanted to peruse the data set, I could go over here and get into my Explorer panel, and I can double-click on Libraries, and you can see I've got several libraries here available to me. Most of these are default libraries that come with SAS. One is the library that I just created, the libref SAS_data, and if I click on that, then you'll see that I've got several data sets available. One of them is the Outlier data set, which when I click on that, it brings up the data set. And so you can see here that I've got 4 variables, the ID variable, which uniquely identifies each observation, and then the 3 continuous response variables. And if I scroll down, you can see that I've got 100 observations. Now, this is the permanent version of the data set. What I could do is back out of this by pressing the backspace key and go to my work directory. Actually, let me close out that data set first. Let's see here. Let me close that. There we go. All right. And if I closed out the wrong thing, so I want to view the Explorer. Let's see if I can find that. There it is. Okay. And so when I double click on work, this is the work libref, the work library. And you can see here that I've got the temporary copy of the data set in the work library. And this is the data set that I'm actually going to use in the program. All right, I think I mentioned it before. I always like to work with copies of my data set, never the actual permanent version. That's a habit that I got into when I was out in industry. As a biostatistician in the pharmaceutical industry, you never wanted to work with a live database until the very end when you're producing the final product. You always want to run all of your test programs and everything on copies of the data set so that you don't mess it up. Okay, so let's close this. I'll close that as well. And let's go back to the program. And so what I can do, and again, we don't want to change anything below this line here. All right, so I'm going to go ahead and run the data set. Run the program to analyze the data set. And let me just scroll up to the top. And so I'm showing here that the structure of the data set using proc contents, just to make sure that I have the right data set. And so I've got 100 observations. I've got 4 variables, all right? So and then I've got my list of variables here. And so I do have the correct data set. And then I have a listing of the data set here that is useful. I may want to go back to that once I've looked at the plots to perhaps help try to find the particular observations that may be outlying. Okay, so remember in this exercise what we're doing is we are restricting ourselves to univariate and bivariate summary statistics and graphical methods to look for outliers, specifically restricting ourselves to the kinds of procedures that you would have learned and are now familiar with from your first 2 methods classes. And so anyway, here I've got the summary statistics and the histograms for x1, x2, and x3, 2 variables. And I think I'm going to focus on the histograms. And if I were to see, a histogram where I've got maybe a bar out to the left or right that's separated from the other bars by spaces, then that might indicate that I've got an outlier. I really don't see that using these histograms. But I can also use the box plots to look for outliers. And remember, what I would be looking for here would be points that are either above the upper, the end of the upper whisker or down below the bottom whisker. And I don't really see that for x1 nor for x2. But I do see a point up here in this box plot for x3. And it's clear here, based on the graph, that this is a data point for which x3 is greater than 2000. So that is going to give me an idea of what I might want to look for. In fact, let's go do that. Let's go back up here to the data set and just kind of scan through. There are only 100 observations, so it won't take very long to scan through. But look for a data point that has a value for x3 that exceeds 2000. And let's see here. So I'm scrolling. I think did I miss that? Let's see here. Did I read that off correctly? Let me go back and look. Yes, so x3, yeah, that is greater than 2000. And okay, so let me go back and look. I think I missed it. Oh yeah, right there. Okay, so I went too fast. So in fact, since we went and looked through the whole thing, we can see here that observation 75 is the only data point in the data set that has a value for x3 that is greater than 2000. And so that is clearly the point that we've identified here using this box plot. We can also use bivariate scatter plots of the points, and we would look for points that seem to be far away from the rest of the data points, kind of separated. And the only point that I can see here would be maybe this point up here in the upper right corner, and it has a value of x1 and x2 both being greater than 100, so that might be something we would want to look at. And then also in this plot for the scatter plot of x1 versus x3, we see this data point up here in the upper right hand corner seems to be kind of separated from the other points, and it has a value of x1 again that is greater than 100 and x3 greater than 2000. So this must be that same data point that has its observation, what was it, 75, I guess. And then finally we see in the scatter plot of x2 versus x3, we see that same data point. And I really don't see any other data point in any of these other scatter plots that would jump out at me as being outlier data points. And so if we go back up here to the listing and look at observation 75, we see that the x1 and x2 are indeed both greater than 100. So this is the data point that I've identified using these univariate and bivariate plots to look for outliers. So observation 75 is the one that I was expecting you to find, and really the only one you can find if we restrict ourselves to univariate and bivariate procedures. Now, I also want to show you how to do this analysis, this search for outliers, using SAS Enterprise Guide. And so let me bring that up and I'll start the video once I get it started. Okay, so I'm back and I've opened up SAS Enterprise Guide. And so you see here we have our process tree over here in the upper left panel. There's nothing there because we don't have anything in process yet. We have our server list down in the lower left panel. And then here in the main part of the page, we've got the process flow panel. This is where we're going to do the work of creating the analysis or analyses that we want. So the first thing I need to do is connect to and open up the SAS dataset. And so I see it here in my list. I'm going to open up the Outlier dataset. And it immediately brings us to a page where we can actually look at, peruse, skim through the data set, and so forth. And so now what I want to do is create the same kind of graphics that we created using the SAS program, but we're going to use it or create those using the point-and-click interface of SAS Enterprise Guide. And so we could, with this particular panel up, looking at the Outlier data set, we could select the analyses and graphics and things that we want using this particular menu. But I'm going to just close out this particular view, and that will take me back to the process flow diagram. So I wanted to do this so that you could see what we've got so far in this process flow. What we have here is the Outlier data set. And that's going to be the starting point really for any analysis. We've got to connect to a data set. Now I can either double click the data set and bring up this view again, or what I could do is just make sure that the data set is selected by clicking on it once and then select the appropriate menu to get the to do the things that I want to do. And so if I were to use this approach, I'm going to perform some tasks, some analysis tasks. And in particular, I want to create a graph. And so, for example, if we wanted to create scatter plots, well, let's look at see if we could produce some histograms and things. Well, let's restrict ourselves to scatter plots right now. So, because this scatter plot matrix will indeed create the histograms down the diagonal. So I'm going to create a scatter plot matrix. And so this is going to ask me what the analysis variables are, if I want to have any grouping variables, and what I want on the diagonal of the scatter plot matrix. So let's start up here with the matrix variables. And notice I do have to select at least one variable. And so what I'm going to do is I'm going to highlight all three. And I can either drag them over or I can press the right arrow button, and it will move all three variables over there. And I don't have a grouping variable, and the chart title, scatterplot matrix, is fine. Down the diagonal, what I will do is have it create histograms or include the histograms down the diagonal. So those histograms will give me the univariate graphics that we looked at from the SAS program. And we could use the diagonal, or we could keep the 95% prediction ellipses or not. I think I'll just turn those off for now. And then we could run the program, and let's see what it does. And by the way, so what's happening here is that as we go through and perform these mouse clicks, SAS is building a SAS program, or Enterprise Guide is building a SAS program based on our mouse clicks. And then it runs that, it submits that program to SAS. And so again, SAS Enterprise Guide is sitting on top of SAS. It's writing SAS programs based on our menu options and mouse clicks, and then it submits that program to SAS. And so we can see here that we've got our scatter plot matrix, we've got the histograms down the diagonal, and we have the scatter plots here in the various cells. Now, those are kind of hard to see, so let me close that out. Let me just run create another analysis, graphical analysis. And so let's just do a single scatter plot. And we need to specify the data. And so I'm going to have variable x1 and x2. And I really don't need to change much of anything else. Let's see here what we have options for. They're really, let's just run this with the default options. And you can see here that, and this is not displaying very large, I apologize for that, but you can see we get the same scatter plot, or the same type of scatter plot that we got when we ran the SAS program. And again, we can see this observation here that is the same data point that we identified before. We could create individual scatter plots for each pair of variables. So I can go back down here and select scatter plot. This time I want to create a scatter plot for x1 and x3. Okay, and I can also create a scatter plot for x2 and x3. So it's as easy as just pointing and clicking and dragging the variables that you want to include. And we can inspect these for outlying data points. Now, instead of selecting the plot functions or the graphical functions specifically, what we can do is we can go up here to describe, and we can ask Enterprise Guide to perform some descriptive analysis for us. And so the option that I will choose here is the Summary Statistics submenu. And it's going to ask us, okay, what analysis variables do you want to include in the analysis? And I want to include x1, x2, and x3. And let's see here. All right, the statistics I want to include, that's fine. Let's see here. Anything else? I think that's it for now. We could include percentiles. What I'm really after right here are creating plots within the context of this descriptive analysis. And so here is another place where we could construct histograms and box plots. And then we could just run the program. Okay, and so here we have the histograms. And again, nothing shows up here. Well, actually, this one right here, we do have, this one does show large values for x3. So this one might give us an indication that there might be an outlier. And Then we also have the three box and whisker plots that we also created using the SAS program. So we have the same kind of results using Enterprise Guide when we restrict ourselves to these 1- and 2-dimensional analyses and plots. Plots being histograms, box plots for 1-dimensional summaries, and then the scatter plots for 2-dimensional data summaries. Now I've added one additional analysis, and this is a 3-dimensional. This is a 3-dimensional plot, a 3D plot of the data points. And so given that we have 3 variables, so our observations are 3-dimensional, this 3-dimensional scatter plot really gives us a way to see the observations in all 3 dimensions. Now obviously this is pseudo 3 dimensions because we're still looking at a 2-dimensional page or a 2-dimensional screen, all right, but it does give us some perspective, and it gives us at least the opportunity to look for outliers in the full 3 dimensions. And so let me see here. So you can see here, and again this is small, and I apologize for that, but you do see the 3 variables. Here, this axis is the x1 axis, and this vertical axis is the x2 axis, and then this axis going into the page is the x3 axis. Now, I want to, one of the things that I can do with this is that I can actually rotate the graph, and so let me get this working so that I can do that. I've got to do something here real quick, so I'm going to pause the video, and then when I get this working, I'll come back. Okay, so I'm going to open up the graphics toolbar, and I'm going to select this button here. This is the button that allows us to rotate the graph. And again, I wish this were bigger because it would be more impactful, but we're going to have to make do with what we've got here. So you can see here that this allows me to rotate the graph, and it allows me to see this from different perspectives. Now, I'm not sure what happened there. I may have to redo this. Let me see. I'm going to have to redo it. So I'm going to pause the video again. And, well, actually, here's what I'll do. I'll just go back out here. We'll see if we can get it to run. Okay, so you can see here that we are getting some error messages. And so let me close that out. Let me see if I can run this again. Okay, so I'm getting some error messages. I'm going to redo this, and I'll start the video once this is redone. Okay, so I had to close down Enterprise Guide and restart it. I'm running Enterprise Guide on Windows, which is running under Parallels on my Mac, and so I don't know if that is the issue here. We're going to try this again and see if we can get this to work without bombing out. So again, what we were doing was we were rotating the graph here so that we could look at this from different perspectives. And the thing I would point out here is that you can see this is the data point that we identified previously. This is, and when I point to it, you can see the values for the variables, x1, x2, and x3. And you can see here that both x1 and x2 are greater than 100, and x3 is greater than 2000. So that is indeed the point that we identified previously. And so when we look at it from this perspective, for example, this is really the same kind of perspective that we saw in the 2-dimensional scatter plots that we created in SAS as well as in SAS Enterprise Guide. But now what I want to do, let me rotate this around just a little bit more, and let's just see if you can see if anything happens. Well, we can see that something happened again, and I can tell that I'm going to have to redo this as well. So when I come back, what we're going to do is I'm going to rotate it to a particular perspective that I want to get to so that we can see what I'm trying to point out. Okay, so let's try this one more time. I'm going to grab this plot, I'm going to rotate it around, and I want you to see if anything, any other data point jumps out. So let me try this. There we go. That's the perspective I wanted to get to. Now, from this angle, from this perspective, you can see that most of the data points fall perfectly on a plane. Now, this point up here, this is the point that we identified using univariate and bivariate graphical summaries, using the box plots and using the scatter plots. This is the outlying data point that we found. But notice that even though it is an outlier data point, it does fall perfectly on this plane along with the rest of the data points. So just because, it could be that this data point is not in error. It may not be an errant data point. It certainly is an outlying data point, but it does follow the trend of the data in the sense that it is on this plane. Now, I'm not saying that every data set like this the points will all fall on a plane. This is a data set that I created specifically to point out some things with regards to trying to find outliers in multiple dimensions. So this is, even though this is an outlying data point, it's not necessarily an errant data point. But I'm sure that this point jumped out at you as soon as I rotated it to this perspective. This is a data point that is different than the other data points in that it is not on this plane. And so this would be an example of a data point that is an errant data point. From the perspective of the creation of this data set, this would be an errant data point, but it's not an easily observable outlier. It is an outlier, but we were not able to see it or identify it from our 1- and 2-dimensional graphical summaries. And so this points out the fact that when we're dealing with data in multiple dimensions, we really cannot rely on 1- and 2-dimensional plots to be able to identify outliers with a great deal of confidence. It's going to be very easy for a data point in multiple dimensions that's an outlying data point to kind of hide in amongst the other data points from the perspectives provided by the original variables as they're measured. And so let me see here. Let me see if I can rotate this just a little bit more. From the standpoint of these other perspectives, that data point really is not an outlier. And so I can see here that this is crashed again, so I'm going to have to close it out. And I'm not going to bring it back up because you see the point. The issue is that there was more than one outlying data point in this data set, but we were only able to identify one using the univariate and bivariate graphical summaries. And that's going to be possible whenever we are looking at multidimensional data, but we're viewing that data from the restricted perspective of 1 and 2 dimensions as those dimensions are measured by the variables. So we're going to continue on here. I'm going to open up, I'm going to do another analysis now. What I'm going to do is I'm going to close out, I've got to close out Enterprise Guide and then restart it. When I do that, I'm going to do a principal component analysis on this data set. And I'm going to show that we can, using principal component analysis, we're going to be able to very easily identify both of those outlying data points. So let me do that, and then I will start the video back up once I get Enterprise Guide restarted. Okay, so Enterprise Guide has been restarted, and so what I'm going to do is open up the data set again, and it's the Outlier data set. And then what I want to do is to perform a principal component analysis. And again, that's under the multivariate menu. And the first thing I need to do is to identify the analysis variables for the PCA. We don't have any variables that we're going to be partialing out, no group variables. And I'm going to run the analysis on the covariance matrix, so I'm not going to standardize the variables beforehand. Okay, the plots that I'm going to use, well, I'm going to create scree and variance plots. I'm going to create a scatter plot matrix of the principal component scores. And then, let's see here. I'll create scatter plots of the principal component scores as well. And, well, we might as well just create all that. Now, I don't want to show the ellipses. And that's all I'm going to need. So I'll run the analysis. Okay, and so you can see here from the analysis that for this data set, how many principal components would we need to use? Well, if you think back to the graph that we saw, all the data points fall perfectly on a plane. And so we certainly would not need to use, well, most of the points fell on a plane, all but one of the points fell on a plane. And so anyway, if we wanted to try to reduce the dimensionality of the data set, we could use less than 3 principal components. In fact, one principal component would account for most of the variability in the data set, 99.61%. But that's really not the point. We're using this particular example to show how the principal component analysis can be used for identifying outliers. And from that perspective, we don't want to limit the number of principal components too soon, and we'll see why. So what I want to do is I want to scroll down here. You can begin to see this in the scatter plot matrix, but I want to find a larger version of these scatter plot matrices. And again, because of how Enterprise Guide is working on this computer, these plots are very small. But what I want to show you here is when we look at the component score. So these are the scatter plots of the principal components themselves. Most of here's the scatter plot of the observations for principal component 1 on the horizontal axis and principal component 2 on the vertical axis. And you can see here observation 75, it's labeled as observation 75 or ID 75. It is somewhat of an outlier from the rest of the observations. And so we easily pick out from this plot the observation that we did identify as being an outlier using our 1- and 2-dimensional plots. And the same thing goes for this plot. We easily pick out observation 75. But now when we look at this plot here, so component 2 versus component 3, we see another observation that is very much outlying from the other data values, the other observations. And it's hard to see, but this is observation with ID 50. Okay? And in fact, from this perspective, it looks like this is much more of an outlier from the rest of the data values than observation 75. And so using this principal component analysis, we're easily able to identify not only the observation with ID equal to 75 as being an outlier, but the observation with ID equal to 50 as being an outlier. And so there are actually 2 points in the data set that are outliers. We were not able to identify both using 1 or 2-dimensional scatter plots of the original data. But when we look at the principal components, we are able to identify both of those outliers. Now remember that the principal components are derived variables. They're indices created from the original variables, and in particular they are linear combinations of those variables. And when we remember that the underlying approach that principal component analysis uses is to identify the dimensions in which or the directions in which we have variability in our data. And so that is why this principal component analysis is able to detect that this point is an outlier from the rest of the data points, because we've identified a direction in which this data point is different or varies from the other data points. And that direction is in particular in the direction of principal component 3. So again, to wrap this up, one of the primary reasons for using principal component analysis is to identify the true dimensionality of a data set with an eye towards potentially reducing the dimensionality of the data by focusing on a fewer number of principal components. But another very important application of principal component analysis is to help you to identify observations that are outliers in multidimensional space, in multivariate space. And for that particular purpose, you don't want to reduce the number of principal components when you're doing that. You want to look throughout all the directions provided by the principal components to look for outliers. Because as we've seen here, the direction in which this particular point with ID 50 was an outlier from the rest of the data points was in the direction which accounted for the smallest proportion of variability in the data set. All right, it was in that third direction, and that accounts for. You can see here the proportion of the variability that direction accounts for, 0.0002. So 0.02% of the total variability is accounted for by that principal component in that third direction. So it may seem unimportant from that perspective, but from the perspective of being able to identify an outlier in that direction, that is a very important direction. So we don't want to limit the number of principal components too soon. We want to look at all the different principal components that are available, and in particular look at scatter plots of those principal component scores to help us identify outliers in multidimensional space. So that is the point of this whole exercise and looking at this data set. Okay, and so we know now that we can use principal component analysis to help us in our search for outliers in multidimensional space. And so it's a very nice tool to have, and it's one of the first tools that we're going to use whenever we do a multivariate analysis. We're going to be using it to look for outliers from in our data set.